Greetings, chemistry students. Today's lesson is going to be a real short one. We're going to talk about what's called valence electrons. So, valence electrons are the electrons in the outermost energy level. And these are the electrons that give an atom its chemical properties. And for the main group elements, and I'll explain what I mean by that in just a minute, the number of valence electrons equals the last digit of their group number. And that's just a quick and easy way to figure these out, but I'll show you how this works. So here we have a periodic table. And so if we just pick an element like, for instance, nitrogen, its electron configuration is 1s2, 2s2, 2p3. The valence electrons are the ones in the outermost energy level. In other words, the second energy level. And so in the 2s and the 2p, that's the ones that are the second energy level, there are 2 plus 3 electrons. So nitrogen has 5 valence electrons. You'll notice nitrogen is in group 1, 5. So it's got 5 valence electrons. Also, when we're doing the shorthand method, if we wrote this as He 2s2 2p3, here we're pretty much just writing the valence electrons. It makes it easier to find them. It's those electrons right there. So I'll give you a few more examples because that was just one example I could pick. If we go with something like, let's go with selenium right there on the periodic table. We write its electron configuration. We go to the end of the previous row where we find argon. And then we go 4s2, 3d10, 4p, 1, 2, 3, 4. The valence electrons in selenium are the ones in the fourth energy level. So the 4s and the 4p. So it's those two plus those four. So it's 6 valence electrons. And selenium is in group 16. It's got 6. Every element in the 16th group on the periodic table has 6 valence electrons. Every element in the 17th group has 7. Every element in group 1 has 1. Now, some exceptions arise when you get into the D's and the F's. When you're in the D and the F region of the periodic table, when you're in this area or down here, all of those elements, we don't use this rule. Because when I say main group elements, I'm referring to the S and P region over here. For all these other elements, like for instance, either scandium or titanium or vanadium, if we were to write their electron configurations, like for scandium, it'd be AR 4s2 3d1, and for titanium, it'd be AR 4s2 3d2. Well, the only valence electrons are the ones in the outermost or the fourth energy level. So they all these elements down here technically just have 2 valence electrons. The other exception that was briefly mentioned on the slide, it says except for helium. That's because although helium is in group 18, and so you would think it has 8 valence electrons, if you think about it for a minute, helium only has 2 electrons total. Its electron configuration is 1s2. It only has 2 electrons, first energy level. So although you would think it has 8 valence electrons, it doesn't. It's only got 2. And these valence electrons are what actually gives elements their chemical properties. And it explains why, for instance, these elements down here in group 1, they all react violently if you put them into water. All of these elements over here in group 17 are super reactive elements. And then we have this group over here whose outer electron shell, their valence shell, or valence electrons, they have a full set, which for pretty much all of them is 8 valence electrons. That's as many as you can have. They don't undergo chemical reactions pretty much at all. That's why they're called the noble gases. They kind of keep off to themselves, like a king or a queen locked up in a castle. They don't interact with other elements.